Well, welcome back here to podcast number 7, where we are going to take a dive into looking at the weak acid equilibria constant versus the weak base equilibria constant in what I'm calling an in-depth problem. You can see that these problems do get complicated relatively quickly, and so hopefully, dedicating this one podcast so that we can see step by step what we need to do in order to solve these problems correctly. All right, so we have a solution of sodium cyanide, and it says that it has a pH of 12.10. We want to know how many grams of sodium cyanide are in 425 mils of a solution with the same pH. All right, we're given the Ka for HCN. All right, so number one, it states that the cyanide ion acts as a weak base. So HCN is a weak acid, right? And so it is a weak acid, which is why it has a Ka associated with it. All right, now what we're going to do then is we're going to set up our equilibrium expression, and we're going to find then our Kb, right? So we know that in this problem, right, we would have that our cyanide, right, which is from the sodium cyanide, but the sodium part of it's just going to be a spectator ion. It's going to react with water. It's going to come to equilibria with some HCN, right? That's the conjugate acid of the cyanide anion base, plus some hydroxides. So we're starting with a base, so we would have a Kb for this would be our HCN times our OH divided by our cyanide anion there. All right, but remember in our problem, we were given a Ka. So Kb is also equal to Kw divided by our Ka. Right? That's the fact that our Kw is equal to Ka times Kb. I've just rearranged that. So 1 times 10 to the minus 14th divided by 4.9 times 10 to the minus 10th. And we're going to get this equal to 2.04 times 10 to the minus 5th. In there. All right. Now, next off, right, it says that for a solution with a pH of 12.10, then our H plus concentration is going to be 10 to the minus 12.10. However, let's notice that the problem there for our Kb has OH in it. And so we really need to find out what our OH concentration is. So I'm going to say, okay, well, my H plus concentration is 10 to the minus 12.10, which happens to be 7.94 times 10 to the minus 13th. And so the OH concentration is Kw over H plus. So 1 times 10 to the minus 14th divided by our 7.94 times 10 to the minus 13th. So we get 1.3 times 10 to the minus second. All right, now we have our Kb and our OH concentration. Right? We have a lot of information here. So let's see what we're going to do in part 3 of this problem on the next slide. Well, it says that we're going to set up an ice table, and we're going to work in reverse to find our initial concentration of our cyanide anion. All right, so again, when I set up an ice table, right, I like to put in ice over here on the left, and then I like to write out my equation. So I have my cyanide plus water. Well, I don't care about the water, so I'm just going to leave it out of this, in equilibrium with our HCN and our OH. So, right, I can start to plug stuff in. I know initially we have none of our HCN or our OH there, and I know that my OH concentration, right, I've got a bunch of stuff up here where I can put in like the changes and stuff like that, but let's just not do that. Let's ignore this for right now, and let's say, okay, I know that at equilibria that my OH concentration is 1.3 times 10 to the minus second. We found that on the previous slide. All right, well, notice that, right, for every one of those that's made, we're making one HCN, so that's also going to be 1.3 times 10 to the minus second. So we know that these are increasing by 1.3 times 10 to the minus second. And we know then that the cyanide has to be decreasing by that amount. All right, well, I don't know what my initial cyanide concentration was. All right, and so up here it says, why don't we call it Y? We can go ahead and call it Y. We can call it anything. Let's just call it some unknown. It could be X if you like X. 1.3 times 10 to the minus second there. All right, so now we can plug in everything we need into our expression for our Kb. So we've got our 2.04 times 10 to the minus fifth is equal to, all right, our HCN, which is 1.3 times 10 to the minus second, times our OH, which is 1.3 times 10 to the minus second, divided by our cyanide concentration, which is Y minus 1.3 times 10 to the minus second. And if we solve for Y, then our Y becomes 8.3. All right, and so that means that our initial concentration here of our cyanide anion is 8.3 molar. All right, now let's move on to our next slide and see what else we want to do, because, right, it doesn't just say that, it says how many grams of sodium cyanide are in 425 mils. We are certainly getting close now. We're on step number 5, which is going to be our final step. Right? We are going to use our 1401, our Chem 1 skills, and we're going to determine the mass of our sodium cyanide needed to make that. So just a reminder that all through this problem, we've only cared about the cyanide part of it. But when we're talking about the mass, we need the mass of the entire thing. So we're going to start with the molarity of my sodium cyanide. Well, the molarity of sodium cyanide is going to be the same as the molarity of our cyanide, which is 8.3 moles of NaCN per liter of solution. All right, I want to get this into moles of sodium cyanide. So I'm going to say, okay, there's 1 liter per 1,000 milliliters times our 425 milliliters. All right, that would give us here our moles of our sodium cyanide. Now we need to finally get this into grams of sodium cyanide. So I'm going to multiply this by the molar mass, 49.01 grams. Right, now that's the mass of the entire thing per 1 mole. And we are going to end up with, right, 1.7 times 10 to the second grams, right, which is 170 grams. And we finally got there. All right, so again, a lot of these problems, there's just a lot of different steps. And so you just need to take your time and be like, what do I know? What from that given information can I get? Right? They are not the easiest problems. I understand that. But hopefully we can kind of continue and work through them. All right, next up, we're going to move on to podcast 8, where we're going to look at salt solutions and whether they are acidic or basic.